Hi students, MCQ number 27. The RMS velocity of a gas is 300 meters per second. The RMS velocity of a gas with twice its molecular weight and half the absolute temperature has to be determined. Very direct question and very easy problem. So first we will take an RMS velocity, okay, V RMS. So this is equal to square root of 3 RT by M. So this is the standard expression we have been using to solve all the previous problems. If molecular weight becomes twice its initial value, so this can be taken as M1 and T1, half the absolute temperature. So M2 is 2 times M1 and T2 is equal to half of that of T1. So the first equation I will take this as what? V1. Okay. So now in the second case, what should be the RMS velocity? This should be equal to square root of 3R into T2 divided by M2. So this is now equal to square root of 3R into, instead of T2 what we are going to substitute? T1 by 2. So this is T1 by 2 whole divided by, instead of M2 we can substitute 2M1. So this is 2M1. Therefore V2 is now equal to square root of 3RT1 3RT1 divided by, this 2 will also multiply with the 2 in the denominator, so that this will become 4M1. Okay, so this is equal to square root of 1 by 4 multiplied by square root of 3RT1 by M1. So this is equal to 1 by 2. So square root of 4 is 2. And square root of 3RT1 by M1 is equal to what? V1. So therefore V2 is equal to what? V1, half of V1. So this is equal to half into 300 meters per second. So this is equal to 150 meters per second. Okay. So which option is correct? Option D is the right answer. Therefore option D is the correct answer. This is very direct question only, okay. So you can also do it in a very shortcut route. V1 is proportional to square root of T1 by M1 and V2 is proportional to square root of T2 by M2. So V2 by V1 directly you can divide also. This is just an explanation for the problem how to solve. So if you practice this again and again, means that the time taken to solve this problem must be only 25 to 30 seconds. I hope you must have understood them fine.